Alright, got another tutorial coming on here. This one is very specific and maybe won't be used as much, but I saw a problem that was very interesting and I tried to solve it and I'd like to share my answer to it, which is given a unsigned integer value that is given by a user, count the number in 32-bit system, count how many of those 32 bits are the bit value 0. And so and also use bitwise operators to do this. So this is very interesting. I think could be a good way to introduce oneself to bitwise operations. So we'll go ahead and jump into it. You already know we need to add the standard IO library. We're gonna make the main function here, and we're just gonna start by declaring unsigned int a setting. That's going to be what the user is going to enter. We're going to take another unsigned int b. And you'll see what we're going to do with b in a bit. But a is what we want we want to prompt the user to enter. So we'll make a print statement to prompt the user. Enter an integer positive. Just to clarify. I mean, it's only for me to use, so it doesn't really matter. And we're going to scanf as usual, but the placeholder for an unsigned integer is not %d, it's actually %u. So keep that in mind. Pass the address of a in order to pass the value that we're entering in there into that address location. And I can explain in another video why this is more efficient. I'll give it like a brief why we pass by address or reference rather than value, because when you pass by value, it starts to make a copy of the variable. This just becomes really inefficient. There is some pros and cons to it, but overall passing by references for scanf is the best way to go. It's the most efficient. Right, so now we've got the value of a. For this, we're going to set b equals to 1. And the reason why is because we just want to give an integer value, or like a value that we can compare with a, we can compare the bits with. So I'm not sure, I'm hoping that if you're watching this video, you're familiar with binary numbers and how to read it. In this case, 1 would be in 32 bits, 0, blah, 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 and then 1. That's binary for 1. If you're not familiar, let's say b equals 2, right, just for this scenario, would be 0, 0, 0, 0, 0, 1, 0. It goes 1, 2, it's basically by 2. So the first digit is 2 to the power of 0, which is 1. Next is 2 to the power of 1, which is 2, 2 to the power of 2, which is 4, 2 to the power of, 3, which is 8, blah, 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 so on. So you can make numbers. Say 3. 3 is just going to be this, because it's 1 plus 2, right? Simple as that. So we just want to compare it to something. Now, what we're going to do to compare it is set a for loop. Yeah. For, you can, if you want, you can declare int I in here. For the sake of this video, I'm just gonna do it here. And I also forgot the most important part: declare a variable for counting the numbers. That's exactly why we're making this video. Sorry, my typing's all over the place. So we'll take I equals 0. For I equals 0, that's an O. Sorry, I don't know what's gotten into me. I is less than 32 because this is a 32-bit system we're reading on. It works for any bit system you want. 64. 64 is more common, but for this case, we're just going to do 32. I plus plus, increment I. So it goes up by 1 value every time. Now we're going to make an if condition. If A and B outside that equals 0, count plus plus. Now what the and does, if you're not familiar with what it does, here I'll make a little thing here. Let's say A equals 0, 1, 0, 1. Yeah, okay, there. B equals there. I'll just do it for the case of this. And C is like, we're using and to compare A and B. C, what would it be? We're going to take the bits of these and compare them. So when you have, we'll start at the beginning here, 0 and 1. Basically, and is checking if they're the same. And if they're not, if they're the same, then you return that value that they are. If not, you return 0. So 0 and 1, are they the same? No. We're going to return 0. 0 and 1, 1 and 0, not the same, return 0. 0 and 1 again, 0. 1 and 1 are the same, so we're going to return 1. And then just for example, if we had another 0, 0 and 0 would be the same, we would return 0. And C would be this value. So that's, I'm just going to keep that there in case you need to look at that, in case you just want to understand what's going on. So here we're comparing them and we're saying that if the value is 0, we're going to up the count by 1. And that basically is checking. It's just checking every single bit. Well, first it's only checking the first bit. So we're going to have to shift it using a right shift operator. A equals a right shift 1. And then it just keeps iterating and iterating 32 times until the count is given. We're going to print out the value, count %d for the placeholder, new line character, put count there, return 0 because, well, we should just do that. It's good practice. And now let's test this out. Before I run it, I'm just going to say we'll input 1. And remember, 1 is 0, 0, 0, 0, 1. Everything's 0 except for that 1. So we can tell there's going to be 31 zeros because there's 32 numbers, and we're just subtracting that 1 away. The rest would be all zeros. Should be 31. 2 would be the exact same because it's 2 would be 1 there instead. And as earlier we saw, 3 is like that. So in 3 there would be 30 zeros instead. So I'll try 1 and 3 as values to test. AI out, enter positive, we'll say 1. 31 zeros, just as expected. We'll run it one more time. We're going to enter 3, and we should expect 30 zeros instead of 31. There we go. And that is how you solve the specific problem. There is the full code for that in case you would like to look at it again. And thank you.